Hi again, friends. Welcome back to another soulful exercise where we explore machine learning through the lens of our most tender quest, the journey to find love. In our previous two videos, we explored self-awareness and self-love, two dimensions in our inner landscape. A dimension, in machine learning, is an attribute that characterizes the data. Our prior focus was on the inner work facing our fears, healing from past pain, learning to trust ourselves. The data we worked with was labeled, be it memories, thoughts, emotions, so we were in the realm of supervised learning. But today, we enter the domain of the external, our discernment of others. This journey unfolds in two stages. 1. The initial encounter, is this person a potential prospect? 2. Further exchanges. Based on what unfolds, do they align with our standards and desires? This mirrors machine learning beautifully. In the first stage, we're working with unlabeled data. We don't know yet. We're exploring. This is unsupervised learning. So let's start with the initial encounter, unsupervised learning, clustering and association. Unsupervised learning throws us in the exciting mess of what's out there. However, we will still rely on data selection, though throw some new steps, others to those we explored in our past two videos. We still need to remove noise, but we're in for some surprises in feature importance. Introducing the principal component analysis that highlights profiles based on combination of original features. In real life, we think of successful people as busy and overwhelming with work. Well, amongst them, we may also be surprised to find the purpose-driven legacy creators who change the world one small-scale project at a time while maintaining a healthy life-work balance. Didn't expect that? That's where the magic of unsupervised learning kicks in. Unsupervised learning highlights two main families of algorithms. For clustering and association, clustering is about grouping data points by similarity. It's like your brain grouping people you meet at an event. The ambitious ones, the creative ones, the kind ones. K-Means is a popular clustering algorithm. It starts with a simple question. How many groups do you want? Large clusters are broad. People who are emotionally intelligent and financially stable. Smaller clusters are more specific. Emotionally intelligent, with a good relationship with their parents, who also has the same taste in art as me. The algorithm centers each cluster around a centroid and then tries to minimize the distance between all points in a cluster and this center. That distance reflects how cohesive the group is. To choose the right number of clusters, we use the elbow method. As you increase the number of clusters, the improvement starts to level off. That's your elbow. And just like life, we care about distortion. Are our categories accurate? Inertia. Are the members of each group truly similar? Done index. How well separated are the clusters? Then there's association rule learning. Think of it as the universe's if-then logic. Like, if someone is a good listener, then they are likely patient and non-judgmental. Algorithms like a priori use support, how often something occurs; confidence, how often A leads to B; lift, how much more likely A and B are to occur together than separately; from encounters to evaluation, returning to supervised learning. Now that you've met people and gathered data, it's time to label it. We return to supervised learning. You now have patterns, preferences, and data to train on. Feature selection. Decide what matters most. Non-negotiables, must-haves, nice-to-haves, bonus traits. You'll also assess correlation, which points out how features change together. Think of the concept of high-value person. Purpose-driven people are more likely to be ambitious, while success comes as a consequence. Mutual information, which surprises us with unexpected traits, which might reveal strong potential. Algorithm selection, assessing people as prospects, may be approached by either classification or regression. Classification is favored by pragmatics, who prefer to go by their checklist. Regression calls for being astute enough to anticipate how a person will act in various areas of life based on what we know of them. Define dataset, make classification. Does this person fit for a prospect? Yes? No? Partially? Make regression. How will this person act in this area? N samples invites us to visualize scenarios of how a person reacts in a certain circumstance. N features sketch a vision of how your life and shared experiences with your dream partner would be. An informative resume, the most important experience you want to share, such as the same love for traveling. Noise describes irrelevant data coming from people whose core value don't intersect yours. Random state refers to the extent to which conclusion drawn from assessing one situation might be replicated in other. Now we match people with models. K nearest neighbors, KNN. Are they similar to people you've liked before? Decision trees. Do they pass your non-negotiables, then your must-haves? Support vector machines, SVMs. They may seem like a friend at first, but surprise, they're your match. Polynomial regression. The deeper the shared experience, the stronger the bond, like love growing over time. Training and testing. Use train test split. Train on all the lessons from past interactions. Test on new encounters. Apply recursive feature elimination, RFE, to remove traits that just don't serve your journey. Fitting the model.fit you've learned. Check permutation feature. Importance. What really matters? Sometimes it's not what we think. Prediction. How well does your people rate our work? It's time to evaluate. R squared, or how much of someone's behavior can you anticipate? MSE, or what surprises can you tolerate? MAE, or could a small issue cause big problems? Precision and recall, or is this truly who you want long term? Apply K-fold cross-validation. Can your model hold up in different scenario during stress, celebration, or distance? Fine-tuning. Can we truly rely on our wisdom? We need to optimize our model, which leads to the learning rate, the size to which we adjust the parameters of our model, and epoch, a full rotation of our training datasets. The learning rate teaches us how often must someone appear for you to validate your preferences. Epochs invite us to reflect over how many full rotations of life lessons reaffirm your standards. Are we sure of our training data? Did we label it accordingly? Machine learning models are often challenged by Gini impurity, or the frequency to which an element might be mislabeled, and entropy, which measures the level of disorder or uncertainty within the dataset. Let's say we dream of a charismatic partner. The outgoing person we just met could be just overconfident, without the proper sophistication to actually magnetize those around them. As for entropy, are we anyhow influenced by what we see on social media, or do we truly follow our values? If we opted from regression models, we may risk allowing bias error, oversimplified assumptions such as desiring children after a certain age, or variance, over-customized behavior that changes too much depending on who you're with. Bias leads to underfitting while variance to overfitting. An underfitting model is too rigid or generic, doesn't capture your complexity. An overfitting is too reactive and adapts too much to specific situations. An ideal model has low bias and low variance. For that, we need regularization, which can be attained through the lasso and ridge methods. The lasso keeps only the most important traits. The ridge method balances everything, even if imperfect. When do we use each? Go for lasso in non-negotiable and must-haves. Go for ridge when balancing the importance of each must-have whenever we're too attracted by the good to have, are willing to turn a blind eye to the essential. Ensemble learning. Integrate your wisdom. Ensemble learning would imply sharpening your senses and having the clearest vision over what we want and what is truly the best for us. Bagging implies separating the training data on different subsets and independently training various models on them. Results are combined through voting for classification or averaging for regression. Assess different scenarios independently, then combine wisdom through voting. Boosting implies training models one after the other, fixing the errors produced by the previous ones. A combination of all models creates prediction. Let each new lesson improve on the last, grow deeper. Stacking implies training different models and use their predictions as inputs for a final model. Combine your insights to make one masterful judgment. Transform. As you evolve, your preferences shift. What once felt essential might fade, while quiet traits become central. Stay open, stay curious, stay loving, stay